Welcome to 1.6 page 5. This is kind of a neat little page right here. I kind of like this one. Use the graph of f to complete the table for f inverse. Now don't forget that here's the graph of f. Our xy's in f would become our yx's in f inverse. There's a shorter way of doing this, but I'm going to go through this one right now. Here we have a point on f. I've got negative 2's get turned into, looks like 6's. I've got negative 1's get turned into 0's. I've got 3's get turned into negative 2's, and 4's get turned into negative 3's. And that makes it really, really clear what's going on here. But this is bypassable, and I'll show you how momentarily. And it will speed us up if we have to do a lot of these, like what we're going to have to do below here. So if f is a factory that turns negative 3's, or excuse me, if f is a factory that turns 4's into negative 3's, then f inverse must turn negative 3's back into 4's. If f is a factory that turns negative 2's into 3's, excuse me, if f is a factory that turns 3's into negative 2's, f inverse must turn negative 2's into 3's. If f is a factory that turns negative 1's into 0's, f inverse must turn 0's into negative 1's. If f is a factory that turns negative 2's into 6's, f inverse undoes that and turns 6's back into negative 2's. Now, can we do that without here? Yes, we can if we understand in f inverse land, x is really y. So we put a y value of negative 3 and we track that across to 4. We choose y to be negative 2 and we track that across to 3. We choose y to be 0 and we track that to the left 1. And we choose y to be 6. We track to the graph and see that we're at negative 2. So bypassable. If you just absolutely have to do this, fine, but I'm not going to do that in these problems below. So use the graphs of y equals f of x and y. We got two different functions here to evaluate the function. This is g inverse of 0. Now, g inverse of 0 means I go to factory g and 0 is the y value because of the inverse. Otherwise, if it was g of 0, 0 would be the x value. So I go to a y value of 0. I don't want to go up to 2. I've already got my y value is 0. I want to go over, oh, this is negative 2. G is a factory that turns negative 2's into 0's, so G inverse must turn 0's into negative 2's. Kind of weird. Now this one's really straightforward. Go to plain old f, put in negative 4. That's an x value. Put in negative 4. And we get out negative 4. So that becomes g of negative 4, coincidentally. Oh, wait. Sorry. Go to negative 4, and we get positive 4. So we get g of 4. F of negative 4. Plain old, that's an x. Negative 4 gives us up 4. G of 4, now we go to g, plain old g. This is an x value. We go over 4, I guess that takes us up 6. Now, g inverse, I don't like this form. I'm going to go g inverse of f of 3. That speaks to me. So is this 3 an x value or a y value? This 3, it's plain old f, is an x value. So on f, I want to go over 3. I guess that's 2. I guess 3's right here. That takes me down 2. This is down 2. Now, on the G graph, is this -2 an X value or a Y value that we're interested in? It's going into G inverse. This is a Y value right here. So we want to find when Y is -2, track to the X, and it looks like X is over -3. Yeah, I'm going to do my little fold thing here. Not crazy about this form. It doesn't really speak to me as well as this. F inverse of G inverse of 6. So is 6 in the G going into the G graph, is this an X or a Y value? Well, it's G inverse. It goes in as a Y value. When G is 6 up here, we get 4. So this is F inverse of 4. Is that 4 an X value or a Y value? Well, it's going into F inverse. It's a Y value. So I don't want to come over here to 4. I want to go up here to 4. It's the Y value of F is 4. Gives us, track back to the graph, gives us -4. So we got to just kind of look at our graph sort of tilted sideways, flipped over. But kind of interesting problems, definitely ones you're going to want to check your solutions. I think you should always be checking your solutions. That's why I provided you with those on the website. But there you have it. That's page 6.